So what I need you guys to do is in Google Classroom in the classwork tab, okay, I put in yesterday in the course materials an activity called graphing practice. Okay, we're going to be getting to that here in a little bit, so you might as well have it open. Okay, but what I want to talk about first is just graphing in general and why we do it and the importance of it and stuff like that. So we are going to be eventually working with this file here, okay, but for the beginning of this, we're just going to talk about graphing in general. Okay, and you do have some notes in your notes package on graphing. So, what's the purpose of a graph?
To display information in an easy way?
Yes, absolutely. To display information in a quickly understandable or concise way, right? I mean, I could write a couple of pages about what's on this graph and give lots and lots of detail, okay? But if I look at this graph right now, okay, it is in the proper format, and as a result of that, I can discern what the relationship is between the two things that are on the graph. Okay, so first off, it's got a title. It says temperature versus photosynthesis. So I know this graph is talking about the effective temperature on the rate of photosynthesis. Right? And then with just a quick look at the graph, I can see that photosynthesis increases with temperature until we get to about 30 degrees or so. And then it just falls right off. Okay? So, without having to read a whole bunch of text, looking at that graph tells me that, in general, increasing temperature makes photosynthesis go up, but after 30 degrees, plants just quit doing it. Okay? And I got that in like 30 seconds, instead of having to read a whole page of text and maybe vocabulary that I don't understand, okay, and things like that. Right? It's a pretty clear graph. Would you agree? Okay. In order for a graph to be clear and give valid information, you have to have some things. Okay, one of the main things is you got to have a title, right? If I just put a graph on there, people will go, what's it about, right? So a graph needs a title, and that title should probably include some kind of description of what's on this. Okay, I might not call this temperature versus photosynthesis. I might give it like a title that would be more like, rate of photosynthesis as a function of temperature, because people can see from the axes that it's temperature and photosynthesis. I don't need to write temperature versus photosynthesis as the title. Okay, sometimes it's good to have a nice descriptive title instead. Okay, and each axis is labeled. Okay, the x-axis is temperature, which means in this experiment, temperature was the manipulated variable. Okay, so your manipulated variable always goes on the x-axis, so that you can see the effect of its change on the responding variable. Okay, so the responding variable always goes on the y. Okay, the other thing a good graph has is a scale. Every part of this graph is uniform. Okay, or every box on the graph is worth the same amount. That way we get a sense for kind of what the effect of this thing is. If I don't make this a scaled graph, what I see on the graph is going to look a lot different. And it's going to kind of go all over the place and not be uniform. Right? So whenever we're building a graph, we want to make sure we have a uniform scale. This all used to be a lot more labor intensive. Okay? Because before there was really good spreadsheet programs, you had to build graphs by hand. Right? And what that meant was you had to look at what your x-axis was going to have on it. Okay? And if it went from 0 to 40, okay, then you had to go to your graph paper and go, all right, how many lines do I have? Okay, I've got, looks like 30 lines, and I got to fit 40 things on there. So 40 divided by 30 tells me every line has got to be worth 1.3, okay, or whatever. Okay, and it would take forever to set these things up. And then you had to go, okay, so this line's worth 0.333, and this line's worth whatever, and then you'd have to add them all. It took forever to build graphs because you had to do all of that labor-intensive stuff manually. Okay? You guys are fortunate. spreadsheet programs are now reliable and readily available, like Google Sheets. Okay, that's what we're going to use for basically all the stuff you'll do for graphing in high school. It'll do a good enough job for that. I mean, it's a basic program, but it does what we need it to do. Okay, so we're going to just plot the graphs. Google Sheets figures out the scales and make sure they're even. Okay, and all you'll have to do is make sure that labels get on there, and that it's got a good title, and then there'll be some operations you'll have to perform with the data from the graph. Okay, but at least now you guys don't have to spend a half an hour building each graph from scratch. Okay? And the problem, of course, with that is when you're plotting the points, it's easy to make a mistake because you start to get bug-eyed when you're looking at all these little crisscross lines, which now we don't have to worry about. Okay? Everyone kind of following me on the structure of a graph? Okay? So a graph's got to have a title, it's got to have uniform axes, okay, with scales on them that are labeled, okay, with names and units. All right, now, they don't have a unit for the rate of photosynthesis. I'm not sure why, and I have no idea what the rate of photosynthesis is measured on. I'm looking at those numbers and thinking it might be milligrams of oxygen, okay, or something like that, some kind of measurement of the waste products or whatever of photosynthesis. Okay, so in this way, this graph is actually missing something, right? It's missing units on the y-axis. Okay, every axis should have a label that includes its title and its units of measurement. Okay, so here's what we're going to do. Okay, we're going to first build our graphs. So I'm going to sit down because I'm going to do this from my computer. Okay, and we're going to look at the Google Sheet that starts out with number of sheets and thickness. Okay, so we open that up. So we go to graphing practice. Open up the Google Sheet. Okay, so it looks like it's going to be sheet number 3. Okay, so if you guys can just click down here on sheet number 3. I'm going to walk you through the process. How many people have built a line graph with Google Sheets before? All right, most of you. Okay, that's good. All right, so to build this graph, here's what we got to do. Put your pointer in cell A1. Click and drag until you highlight all of the data. Okay, then you're going to go to Insert. And you're going to scroll down to Chart. Okay, now at this point, Google Sheets tries to figure out what type of chart will be best for your data. In this case, it should have picked a scatter plot. That's what this is. Okay, it shows the points scattered about the plot area. Okay, did anyone get anything other than the scatter plot when they did what I just did? Okay, good. All right, so we've now got our scatter plot, and look at this. We've got, okay, a title, which probably could be better. Okay, we've got our label on the y-axis, thickness in millimeters, and we've got number of sheets. We don't have to put a unit there because number is the unit. Okay, everybody with me so far? Okay, now I probably want to change my title, right? So if this is all set up here in the setup part, if this is all set up, okay, I don't need to do anything else with it. It looks the way I kind of want it. So I'm going to go over here now to Customize. And when I click on that, you can see that what appears here changes. First option is Chart Style. We already did that. Okay, Chart Axis and Titles, click on that. Okay, now right underneath there you'll see this field here. Right now it says chart title. And underneath that is this whole thickness, millimeters versus number of sheets. Okay, I don't like graph titles that are, here's what's on the X and here's what's on the Y. Because I can see that by looking at the graph. I don't need the title to tell me that. So the title should be something a little bit more meaningful. Okay, for me I'm going to call this book thickness graph. Okay, that is, after all, what this is a graph of. It's going to tell me how thick a book is based on the number of pages it has. that, you got some options. You can change the font, and you can change the size, and you can change the color and make it italicized or whatever. You can do whatever you really want with that. I never really change any of those because I don't think it's necessary. Okay, so the next thing we want to do, if we needed to do this, for this graph we don't because we laid out our spreadsheet the right way. We can also click here where it says chart title, and it'll give us the options to change the title on the x-axis and the title on the y-axis. Ours are okay because of the way I set up the spreadsheet. Okay, so we don't need to mess with either of those. We're just going to close up the axis and titles. Then we're going to go down to series. Okay, when you click on series, okay, you get some of these options. The type of points are, okay, so we've got thickness, whoops, okay, we've got thickness there. I can make those points a different color if I want to, okay. I can also make them different shapes, okay. I can make them triangles or squares or diamonds or stars or whatever. I'm just gonna leave it as circles, okay. I typically make the points smaller, okay. So they default to 7 pixels, and I usually put them down to 2 pixels. That's entirely up to you. I would not mark your graph wrong if you left it at 7, but some of the experiments that we do, sometimes the points are, there's so many of them that they overlap each other a lot when they're 7 pixels, so we make them a little smaller. All right, if we keep scrolling down here, you'll see there's these check boxes, error bars, data labels, and trend line. We don't need to worry about the error bars or the data labels, but we do want to get a line of best fit. Okay, how many people have heard that term before? Best fit line. Okay, what term did they use in math? You want to remember what they called the line that goes on the graph? Did they call it a trend line?
I think so.
Okay, because typically in the science department we call that a line of best fit or a best fit line. Trend line is also fine. Okay, what we're basically going to do is, instead of having to judge this and in the old days put a ruler on there and then draw the line with your pencil, okay, we're just going to ask Google Sheets to use its algorithm to draw a line that represents the average or the trend of the points. Okay, so we're just going to check the box that says trend line. And as soon as we do that, you'll see that there's a line that goes on there. And on this particular graph, because it's a very simple graph, it goes through every point. That's very rare. Okay? Very, very rarely does the best fit line ever go through every single plotted point. In fact, it's a good chance it goes through none of the plotted points on most graphs. Okay? But it does follow their trend. In this case, going up. Okay? All right, the next thing we want to do, once we click trend line, more options show up down below. Okay? And one of those options is the label for the line. Okay? Right now it's defaulted to none. So we want to click on that, and it says custom or use equation. You want use equation. Okay, and once I click on that, I get this little equation right here. Okay, Google Sheets writes it a little bit differently than we do. Okay, it typically writes it as just, it doesn't have the y equals part that is normally on there. And so as a result, we're going to have to kind of just know that that's what it does, and we're going to have to just adjust that accordingly. Okay. So my graph's got all the stuff on it now that I want. It's in its proper format. I've got my trend line, and I've got my equation for the line. Okay? Everybody follow me so far? Has everybody got a graph that looks like this now? Yeah? Okay. So now, what we're going to do is we're going to do some calculations with that graph. So we're done with the chart editor. We can close it up. Okay? So the reason we got a graph that looked like this was because of the way we set up the spreadsheet. When you're entering data into Google Sheets, whatever goes in column A is going to default to the x-axis. All right, so whatever you want to have on the x-axis goes in column A. Everything else from there forward will be plotted as points for the y-axis. All right? So if I have several different sets of data, okay, like let's say I was graphing the position of a bunch of people running in a race, okay? I would go like time here, and then I'd have the position of all the different people, and there'd be a whole bunch of different lines on the graph, okay? So there'd be like a bunch of different data sets, okay? X-axis goes in the first column, and everything else that you put on will go in on the y-axis. All right, so now that we've got our graph, we're going to go back and we're going to look at the questions that I had written out. We're going to walk through them together for this first graph, okay? All right. So this is what we have, okay? We have this graph built, okay? And it says, calculate the following using your graph. Okay, how many people have calculated stuff for a line graph using y equals mx plus b? Okay, how many people have taken Math 10? Okay, if you've taken Math 10, you've done this. Okay, whether you remember it or not, you've done this. Okay, all right, so when Google Sheets spits out its little equation that we had at the top of our graph, it's saying that for this graph, y equals 0.15 times x plus 5, okay, or y equals m times x plus b. The way that equation is set up is as follows. Y is the y value of a given point on the graph. X is the x value of that same point. Okay? The 0.15, or m, what does m represent? Anybody remember? It's the slope. Okay? Slope is one of the most important things we can get from a graph because it tells us the relationship numerically between x and y. It tells us how much y changes as a function of x. Okay? And then b is our y-intercept. It is the value of y when x is 0. Okay? So basically it's your starting point for any particular graph. Okay? Now, this graph is a graph of book thickness versus the number of sheets. Okay? So, when there are, basically what this graph is telling me is when a book has no sheets, it is going to be about 5 millimeters thick. How is that possible? If it's got no sheets, how can it be 5 millimeters thick?
Is it like front and back cover?
Yeah, it's the cover. Okay, so a book cover, on average at least, according to this graph, is 5 millimeters. Okay, m, the slope, is telling me basically how thick each page is. Okay, y tells me the thickness of a book, and x tells me the number of pages. Okay, so the first question there says, calculate the number of sheets in a book that is 80 millimeters thick. All right, so when I have a graph and I get a question like this, I need to understand a couple of things. First off, which axis are millimeters on? Y. Okay, so they are giving me y. They're telling me y equals 80 millimeters. What are they asking me to calculate? Okay, number of pages, which is on the x-axis. So they're asking me, calculate x when y is 80. Okay, so they've given me this, or the graph has produced this equation. Y equals 0.15 times x plus 5. And I know what y is. Y is 80. Can I solve for x? Okay, that's what we're being asked to do with this graph. Solve for x when y is 80. All right, so what do I have to do with that equation? I have to manipulate for x. Okay, so y equals m times x plus b. This is actually one we did the other day when we were talking about the rules of algebra. So quick review. The rules of algebra are, if I want to move something, Okay, move what's not attached first is rule number 3. If I want to move something, I do the opposite. That's rule number 1. What I do to one side, do to the other. That's rule number 2. Move what's not attached first. That's rule number 3. Okay, even though in this case we got to do rule number 3 first. Okay, so I know those rules are like really like backwards. Okay, they totally are. It's like move what's not attached first. What to do first is rule number 3. Okay, that's like having bomb disarming instructions that say cut the red wire, but first remove the fuse. Like, oh, that's great. Kaboom, right? I know they kind of go out of order. Okay, so I need to move B first. B is not attached to X. M is attached to X. So what do I do to move B? Subtract, right? I subtract it over to the other side. So I'm going to have y minus b equals m times x. Okay, what do I do to get x by itself? Divide by m. Okay, sorry, I thought that's what you said. That's what you said. That's what I heard. Okay, so y minus b divided by m equals x. Okay, perfect. Now I can plug in my numbers. They told me y is 80 millimeters. Okay, and B is 5. Okay, and M is 0.15. Okay, so what I'm doing is going millimeters minus millimeters. So I'm taking the 80 millimeters and subtracting the cover, the 5 millimeters of the cover, so I know how thick just the sheets are. Then I'm dividing by how many millimeters per sheet, which will leave me with sheets, right? If this is in millimeters and this is in millimeters per sheet, then I'm going to be left with sheets. Okay, I'm solving for x, that's the number of sheets. Okay, so if I go 80 minus 5, so 75 divided by 0.15, okay, so 75 divided by 0.15. Okay, so that's a 500-page book. And if it's 80 millimeters thick, it has 500 pages. Or sheets, we should say, because that's the unit they gave us. Okay, everybody all right with that? Now, question number 2 says, calculate the thickness of a book that has 805 pages. Okay, what did they give me this time? Y or X? They gave me X. Okay, sheets or pages is on the X-axis, so that's an X value. So I know X is 805, and I'm looking for Y. Okay, do I have to manipulate this equation then? No, it's already set up to solve for Y. All I have to do is plug in the numbers. All right, so I'm going to have 0.15, because that number never changes, times 805, okay, plus 5 millimeters for the cover. So 0.15 times 805 minus 5. I don't know how you get 0.75 sheets, but we'll have to say that this is probably 116 millimeters, okay, for this one. All right. Everybody okay with that? Did I subtract 5?
Yeah.
That's why I did it wrong. I should have added 5. There you go. I think it's still going to give us our, yeah. No, we still have 0.75, but it's 126 pages now. Everyone, is that better? That's probably what you guys got because you didn't screw it up like I did. Okay. All right, and then question number 3 says the number of millimeters per sheet. Okay, so which part of my equation is going to tell me millimeters per sheet. No, y is going to tell me thickness. Okay, thickness is on the y, number of sheets is on the x. Okay, so I've taken care of y and x. Okay, b is also a thickness because it's a y value. So we're left with m. M is the slope of the line. Okay, and the slope tells me that every sheet is 0.15 millimeters. Okay, millimeters per sheet. Here's how I get that. Okay, so if I've got y equals m times x plus b, and I solve for m equals y minus b over x. Okay, so these are both y values, and what's on the y-axis is millimeters. What's on the x-axis? Sheets. My units for m are millimeters per sheet. Okay? Your slope always tells you the rate of change of y over the rate of change of x. You may have been taught this in math. You may have been taught that slope equals rise over run. Does that sound familiar? Okay, and it's true. Okay, sometimes people teach it like this and they say y2 minus y1 over x2 minus x1. Does that look familiar to anybody? Okay, we're doing the same thing with this. Okay, this formula here is the same as that. Y is y2. B is the first y value. It's what y is at when x is 0. So we're going y2 minus y1 over x2 minus x1. The reason I only put x here is because at b, x is 0. Anything minus 0 is itself. Okay, so that's why we only write x. All right, so these two formulas are the same. All right, so we're going to practice this. We are going to have you guys now build. So if you guys can go back to sheet number 1. And actually, let's try. Let's actually have you do this one. Okay, so go to sheet number 2. For some reason, it's past sheet number 3. Okay, go to sheet number 2, and I want you guys to do what we just did. Build the graph. Okay, I'm going to give you a few minutes to try and do it yourself before I build it. Okay, and then we'll answer some questions to do with it. Okay, let's look at building this graph here, guys. So I'm going to highlight all the data. I'm going to go to Insert. I'm going to go to Chart. Okay, I get the right kind of graph. It's got time in seconds, position in meters, so the labels are all good. I'm going to go to Customize, okay, and just change the chart title, okay. Wow, struggle with real big location. Okay, and then I'm going to go to Series. Okay, everything is good there. I want my trend line. Okay, now on this trend line, you can see it doesn't, like, it kind of goes through the points, but not really, especially if I make them smaller. Okay, very few points actually are directly intersected by the line. That's more like what happens on graphs. Okay, all right. So I've got those in there. I don't have a label yet for my line, so I'm clicking here on label where it says none, and I'm getting my equation. So now I've got my equation there, and my y-intercept is negative. Is that okay? It's 100% okay. There's absolutely nothing wrong with having your y-intercept be a negative number. Okay? It just means your graph starts before, like, whatever your reference point is. Okay? So it just means they started like behind whatever, if this was like a start line and a finish line, they started behind the start line. Okay, no big deal. All right, so we've got everything we need there. Graph is built. Okay, so it really doesn't take very long to get a proper graph built. Like that process, I kid you not, when we had to do it by hand, that process would take an experienced graph writer at least 20 minutes. Okay, so yeah, you guys can do it in a minute.
1 second.
Or 20 seconds if you go really fast. All right, so now we're going to look at what do we have to do with this graph. But before we look at that, what's on this graph? What is this graph telling me? Spoiler alert, it might be in the title.
It's almost like the object location and position in time.
It's telling me, yeah, where the object is at various points in time. Okay, it's like if I was doing like a GPS track on somebody, okay, that this is where they are. Okay, at time 0, they're at a position of negative 0.801 meters. So if this was my starting line, okay, the green tape on the ground, I would be about right here, right, behind it a little bit, right? And then at various points, the person obviously walked in which direction, forward or backward. Does their position become more positive or more negative? Becomes more positive. Okay? Like they started below 0, okay, but they finished at almost 60 meters. So they definitely walked forward. They started from here and just kept going, okay, and walked forwards. Okay, so on the x-axis I've got time. On the y-axis I've got position. There we go. Okay, so I've got this graph here, right? I've got my equation, and it says that y equals m times x plus b, okay? And in this case, that's 3.85 times x plus negative 0.801. Okay, what do you suppose the slope represents on this graph? And this is like one of the most important skills we have to have, okay, in science, is to be able to look at a graph and know, okay, the slope is telling me this from this graph. That is exactly what it's telling us. It's actually velocity, but we'll say speed because they walked in a straight line, they would be equal. Okay, but this is telling me the velocity at which someone is walking. Right? Because it's showing me their position, where they are in meters, changes over time. Right? Displacement is your change in position. So when we're looking at this formula here, here's what we're really looking at. Okay, this is the same formula because the way we calculate displacement is final position minus initial position divided by time. That is exactly the same formula. Position is on the y-axis. Time is on the x-axis. That formula we've been using is derived from this graph. Okay? V equals d over t calculates the slope of a position versus time graph. Okay? All right, I would like you guys, using that graph, to answer those two questions. I will give you a few minutes, and then we'll go through them together. Okay? I want you to calculate the position of the object after 1 minute, which is how many seconds? Okay? And how long it'll take, so time, to reach a position of 150 meters. I want you to answer those two questions, show your work, okay? And then we'll go through them here in a minute. Okay? And I want you to use this equation to do it. Okay, use the graphing equation to do it. Okay, let's have a look at number 1. What are they asking me to calculate in number 1? Y or x? Y. Okay, position is on the y-axis. They're saying, what is the position after 1 minute? Well, time is on the x-axis, so they gave me x and said, calculate y. So all I have to do then is go, all right, y equals, all right, according to my graph, 3.85 times 60 seconds plus negative 0.801. All I have to do is plug in the numbers. It's already set up to solve for y. I don't need to manipulate the equation at all. So we'll have 3.85 times 60 plus negative 0.801. We could have just subtracted it as well. So the position of the object after a minute is going to be positive 230.2 meters. All right, everybody okay with that? What we did there. Okay, what is number 2 asking me to calculate? X. It's saying how long. Time is how long, so they're asking me to calculate x when the position, y, is 150 meters. So now I've got to manipulate. Y equals m times x plus b. I want to isolate x, so I'll subtract b from both sides, and I'll have y minus b equals m times x. I want to get x by itself. I'll divide both sides by m. So we'll have 150 minus negative 0.801, so we'll actually be adding it, and then dividing by 3.85. $150 plus 0.801 divided by 3.85. So that's going to take 39.2 seconds. These are exactly the kind of calculations I'm going to ask you to do.
Do you want us to do decimal numbers even if all the numbers are in there?
Yes. Yeah.
Are you just gonna give us like a graph like this for our quiz tomorrow?
Probably not yet.
Okay.
Yeah, we'll probably do a little more graphing before I quiz you on it. Like Tuesday I'll give you a graphing quiz. Tomorrow probably still be equals to everything. Questions on this graph? Okay. I want you guys to go to the length versus force graph. Okay, so that is sheet number 1. Okay, I want you guys to plot that graph. Okay, so you already have the data there. Okay, I want you to plot that graph and then answer those questions. Okay, so we got length of the rubber band, we got the stretching force. All right, I want you guys to answer those 3 questions. Okay, for me there. Okay, give you a few minutes on that, and then we'll walk through it together. So, first question is asking how long will the rubber band be if it's stretched with 15 newtons worth of force? So, am I being asked to calculate y or x? Y, yeah, because length is on the y-axis. Newtons, which is the units for force, is on the x-axis, and they gave me that value. So all I have to do is take the equation that Google Sheets calculated for me and say that, all right, y equals 2, okay, that's the slope of the line, times 15 newtons plus 6.5 centimeters. All right, so that should be 36.5 centimeters. Yes? Okay. Question number 2 is asking what force is needed to stretch the rubber band to a length of 18.7 centimeters. So what are they asking me to calculate there? X. Okay, they're asking for a force. Force is on the x-axis, and that's the thought process we want to go through when we're solving a question like this. Y equals m times x plus b. Okay, subtract b from both sides, then divide both sides by m, and I'm solving for x. 18.7 minus 6.5, so y minus b divided by 2 will give me the amount of force that's necessary. 18.7 minus 6.5 divided by 2, 6.1. 6.1 newtons worth of force. Okay, how long is the rubber band when it's not stretched? 6.5 centimeters long. Okay, and I can read that from this equation. B is the y-intercept. It's the value of y, in this case length, when x is 0. When there's no stretching, the force involved is 0 newtons. So the length of the rubber band is 6.5 centimeters when there's no stretching. What does the slope tell me in this graph? If we solve for m in this graph, so m equals y minus b over x, the units on the y-axis are centimeters. The units on the x-axis are newtons, or the units for force. So what is the slope telling me about the rubber band on this graph? Centimeters per newton. Okay, it's telling me how much longer it gets with every newton of force. According to this graph, how much longer does this thing get every time I add another newton of force? 2, right? This is m right here. M is 2. That's telling me that that's 2 centimeters per newton. It gets 2 centimeters longer every time I use an extra newton worth of force. Okay? Those are the kinds of analysis that you're going to be asked to do with a line graph in this class. Okay? All right. What have we got on this sheet here? We got one more thing on here, right? Okay, I want you guys to go to sheet number 4, and I want you to build this graph, okay? And then there's some questions about it. Okay. Nope, that's not it. All right, so for right now, just build the graph for sheet number 4. Okay, that's this one here. Okay, so build that graph, and then I'll put the questions up for that graph here in just a minute. Okay, so just to walk through this really quickly here, guys, to get that graph built. Okay, insert chart. Okay, you can see it does that there. It does exactly what it's supposed to do. Okay, so we're going to go to axis and titles, and we're going to call that Disney Star Wars graph. Because everything Disney's made, with the exception of Rogue One, and of course, Mandalorian, has made people not want to watch it anymore. That whole Last Jedi thing. So, that's what we'll call it. And we're going to go to series, and we're going to get the trend line on there, and we're going to get the equation. Perfect. Okay, so we've got exactly what we need there. Okay, and if we go to our, okay, so this is our graph, and these are the questions I want you guys to answer. Okay, so we've got the viewership in millions of viewers, okay, and we've got time in years, okay, on the x-axis. All right, so I want you guys to answer those questions. Question number 1 just to give you a heads up, requires no calculating. Okay, question number 1 requires no calculation. 2 and 3 do. All right, so question number 1, as I said, does not require any calculating. Okay, it says, what's the rate of decline in viewership? Well, this graph is showing the number of viewers as a function of time. What part of the equation, okay, y equals m times x plus b, which part of that shows me the rate at which viewership is declining? The 3.17, right? The slope. Okay, the slope of our best fit line is showing us, on average, this many fewer people watch this every year. Okay, that's what it's showing, the rate of decline in viewers. Right? That means the rate of decline of viewers is 3.17 million viewers per year. Okay. All right. How many viewers will there be 2 years from now? Now is always the end of the graph. Okay? We can't have a graph of imaginary data. This is data that has to be recorded. This is our last recorded data point at 15. So 2 years from now is 17 years. Right? So we want to calculate y when x is 15. So negative 3.17 times 17 plus 63.7. All right? Why is the slope negative? Why is m negative on this one? Right? Right. Let me look at my line. This is the first graph we've had where the line goes down. All the other ones, the line went up, so the slopes were positive. They show an increase. Negative means there's a decrease. All right, so when we do this, we're going to have negative 3.17 times 17 years plus 63.7, the initial viewership. All right, so that, well, there's only going to be 9.81 million people watching in 2 more years. And if you are a stockholder in Disney, you don't want that as a number. Okay? You don't want this graph to exist. You want to make better stuff. Okay. And in their defense, Favreau and Filoni have made better stuff. If you don't know who those people are, it's okay. I'm a super nerd and I understand that. Okay? They're the 2 people who made The Mandalorian and Clone Wars. They're really good. Okay. All right. When will the viewership be 0? Okay, which axis is viewership on? The y-axis. So they're telling me when y is 0, what's x? Okay, we're looking for when will there be nobody watching according to this graph. Okay, so I want to calculate x, so that'll be y minus b over m. So when y is 0, minus 63.7, divided by negative 3.17. So, negative 63.7 divided by negative 3.17. Oh, that's not negative, that's a minus. Negative. Well, they got 20 years to fix it before nobody will be watching. Okay.
It takes a while to hit rock bottom.
It does. Sometimes you gotta hit rock bottom before you start climbing out of the hole. Okay, everybody all right with how those are working? Okay, we're gonna spend time on that, so don't panic if you don't get it today. All right, if you go back into Google Classroom, I put a different file in there just because I want to show you what this looks like when we have more than one data set. Okay, so if you look in here in the graphing practice, you'll see that I added a second file. Okay, it's called, yeah, I think it's this one. Yes. Okay, so you'll see right here, if you open, can everyone just open that one up? So it's the top one, okay, graphing with Google Sheets. Okay. And when you open it, you're going to see that it says View Only. Just click on File and make a copy, and then you'll be able to edit it. Okay, and And what I want you to do is go over here to where it says multiple runs, okay, or multiple run graph. Okay, and you'll see this sheet here. Every graph we've built thus far has had an X and a Y. This one's got one X and three Ys. Okay, so I just want to kind of show you what that's going to look like. Okay, it doesn't really change what you're going to do in terms of building the graph, but we want to make sure we show that it's got three different sets of data. All right, so click and drag, highlight all the points, same as we did before. Okay, but this time we're highlighting all of them. And then insert your chart. Okay, now, this is where Google Sheets starts to make mistakes. It's trying to read your mind and failing, okay? It thinks you want a bar graph. You don't. You want a scatter plot. So right here, where it says chart type, and it's selected column chart, you want to click on that and scroll down until you get to scatter, and you want a scatter chart. Okay, so clicking on chart type, okay, you'll get the scroll down here until you get to scatter. When you click on scatter, you get this, okay, which looks more like what we've been doing. Then you're going to go to customize, same as we did before. Okay, and we won't bother changing, well, you can see that we're missing a y-axis title here. And the reason that we're missing it is because there were three different sets of data, and it doesn't know what to call them. Okay, so what we want to do is obviously change our vertical axis title. Or actually add one, because it didn't have one. Okay, and that's position in meters. Right, you can see it updates it automatically. Okay, then I'm going to scroll down to series because I want to get my trend lines, plural, many trend lines here. Okay, so I'm going to click series and click on trend line. And you can see it draws one for each set of data. Okay, it treats them separately, and I get three different trend lines. And then I need to scroll down to label and get the equation, same as we did before. But now you can see it makes a legend over here on the right that has position of cart 1, and it gives you y equals mx plus b for cart 1, for cart 2, and for cart 3. Okay, so it doesn't really change what we do, except we'll have to add a velocity, or have to add a y-axis title, and we get three different sets of data instead. Now, this is a graph of position, so where the object is, as a function of time. Based on what you see on my graph here, which car is the fastest? Which one? The yellow car. How do you know that? Okay, so its line goes the highest? Okay, yeah, I mean, they all drove for 5 seconds, and car number 3 went the furthest. It also has the biggest what? Right, the biggest slope, and slope is velocity here, okay? Here's a question.
When I combine, it says no data.
Did you highlight all the boxes? Oh, you gotta highlight all of it. That's why it's saying no data. You can give it any numbers. Now, if you go insert. Okay, guys, if you can log out, shut those down, wait for them to shut off, then close the lid, bring them up here, plug them in, put them in the right slot. Please and thank you.
remember I was so proud of it.
Oh, yeah.